Well, welcome back. This is going to be our third tutorial in the series. This is the Default Tower Defense series. And in this particular tutorial, we're going to focus on towers and defensive positions. We're going to look at how do you deploy a tower, how do you drag and drop that tower, how do you place it into one of many defensive positions. My name is David Chadwick with Tactics Studios. I hope you enjoy this series. Let's go ahead and kick off tutorial number 3. Let's just take 1 minute, make sure we know where we are. This is our roadmap for all 6 tutorials in this series. As number 3, we finished this one. We're halfway there. We're at the milestone. This is going to focus, as I said in my quick introduction, we're going to talk about prototypes associated with our defensive positions, and we're going to talk about a factory that allows us to spawn multiple defensive positions all the way around the screen. We're going to have a collection prototype, in fact 3 of them, one for each of the 3 tower types, and then collection factories that allow us to spawn those towers as we introduce those to our game. We're going to talk a little bit about our cursor game object and our drag and drop design mechanism that allows us to touch the screen, drag the tower, put it into position, and if it's not an appropriate position, return it back to the asset box. And then lastly, we'll have a couple quick changes to our graphic user interface to accommodate that staging of towers down in basically a tower asset box. So let's go ahead and kick this tutorial off. Okay, our intent here in tutorial number 3 is to analyze a completed Build 3 Defold project. That's going to be a project that focuses on the spawning of towers and to drag or drop those towers to designated defensive positions across the map sheet. I thought it would be helpful to initially take a quick look at the assets and the objects and the components that are integral to this Build 3 project. And we're going to use that as a precursor to the rest of this tutorial that'll go into deep details on each of those elements. Now, as a quick reminder, I've included a full copy of this Build 3 project within a shared Google Drive, and the link to that drive is provided down here in the YouTube comments that you'll see here below. Okay, first up, we're going to open up the entire project here in the asset window. Let's start with the game.project. As you can see here under title, it reflects the fact that it's Build 3, that it's focused on tower deployment. We can see that our bootstrap remains the main.collection. And lastly, we can see that we haven't changed the display resolution from what we had in build number 1 and build number 2. We're retaining the same 3 fonts that we used in our previous tutorials and the same 2 Lua modules, all of which were established at the beginning of tutorial number 1. Now, if we look at our scripts, you can see that we have a number of new scripts, and there are going to be some changes. So I've conducted a diffnow, that's that diffnow.com utility that allows us to compare 2 script files. And let me open up a whiteboard here, and we'll take a look at each of the statuses for each of these new script files. You can see the controller script, the enemy tank action script, the mainMenu GUI script, all have changes to them. We had those in our previous tutorials where we've made modifications associated with adding the tower collections to our project. We have several brand new scripts: cursor, defpause, and tower actions.script. Those are brand new for this particular tutorial. And then we have several scripts from our previous tutorials where there's no changes whatsoever. We've got the enemy highlight script, we've got the map sheet, we have the pop-up window GUI script, and the trademark action script. So now as we review the assets here within our asset window, we do see several new elements. There's a new defpause prototype game object, and there's 3 new collections. There's a Tower 1 parent collection, a Tower 2 parent collection, and a Tower 3 parent collection. Let's now open up our main collection. We can see here that there are 6 brand new game objects that have been added to the foundation we completed within Build 2, and those new game objects and their subordinate components are going to be really the target for detailed review within this tutorial number 3. We have the aiming point, which is a simple game object. We have create def pos, which contains a factory. We have 3 of the create tower collections. We have create tower 1 with a collection factory, create tower 2 with a collection factory, and create tower 3 with a collection factory. And lastly, we have a cursor, which consists of a collision object, a label, and a script. So, hey, it's time to roll our sleeves up. I think actually you're going to find that this tutorial is a little bit simpler than the last one, mostly because we're going to leverage many of the same design constructs that we saw for tanks, only this time we're going to apply them to the towers. Okay, let's jump in. Okay, got to have a plan. So in this case, our plan has got 5 steps in it. We're going to keep it relatively simple. We're going to be basically dissecting a completed project. As we've said before, if you look down here in the notes, there is a shared Google Drive where you can download a zip file that's got this full project and all the elements associated with it. One of the things you might want to consider doing is having YouTube showing on your screen and have the default engine in your screen. So as I go through it, you can go through it at the same time. Obviously, that's your call. So what are these 5 steps? We're going to first look at the towers. We're going to look at the collections that are prototypes associated with each of those 3 tower types. We're going to look at the collection factory that allows us to spawn them. That's the first step. The second segment will be associated with the defensive positions, both the prototypes and the factory associated with them. The third step will be associated with our cursor game object that provides us the drag and drop features that we need in the game. We're going to spend quite a bit of time on the cursor script. We're going to do a real deep dive into that script so you fully understand it. And we're also going to talk about the distinctions associated with the various collision objects that we're going to apply to our towers to allow us basically 3 distinct functions: the ability to drag and drop it, the ability to see whether a tank is within range of the tower, and lastly, the collision object when a bullet tinks the tower. So we're going to spend a little bit of time on that. In the fourth step, we're going to do a syntax deep dive into the controller, the changes that we've made since Build 2. We're going to talk about changes to the enemy tank actions, and we're going to talk about changes to the main menu GUI script. And in the final step, that's really a wrap-up, and we'll take a look at what that final result looks like, and just to make sure that everything is copacetic. So we begin our deep dives in segment 1. Segment 1 is going to focus on our tower collections. The tower collections, of which there are 3, one for tower type 1, one tower type 2, one tower type 3. We're going to look at each of the components, each of the elements of those collections, which are really going to serve as the prototypes for a collection factory that will build into our main.collection that allows us to spawn towers into the tower asset box. And then we're going to take a look at the drag and drop capabilities associated with how we construct the collision object that supports the drag feature. So as we said before, the core of this build will be the introduction of towers onto the map sheet. Our design is one where we're going to establish a prototype for each of the 3 types of towers that would be available to the player. Then we're going to use a factory that will allow us to spawn those towers as one of the key features of our controller script. So let's first take a look at Tower 1 prototype and use that as a template for the other 2. We see a similar configuration here to that we walked through for our tanks in the previous tutorial. The first thing we see is that this is going to be a collection. Now let's take a closer look. In the outline window, we have the parent game object tower. Its X and Y's positions are going to be set dynamically in our code, and that'll reflect the location of both the parent and all the child game objects. But importantly, we're setting the Z index to 0.1 that will place this collection on top of the map sheet. There's a child game object for the strength indicator. In the property window, you can see that it's located at x of -2 and y of 7 with a z-index of 0.1. It also has a sprite component that has an image sourced from the Graphic Assets Atlas using the unit strength 3 single image animation group. But as the project did for the tanks, it's also for the towers going to make the strength indicator an animation that we set dynamically in our code. We have a tower body game object that's also a child to the tower parent. You'll notice that it's at 0, 0 in that it's going to be centered on that tower. It has a z-index set to 0.3 with a sprite as a component. And that sprite is sourced from our Graphic Assets Atlas using the default animation Tower 1, 1. We do have a label as a child under tower, and we're going to be using that during our debug process, mostly to keep track of tower strength, particularly when we get into fire exchanges and resources and health implications of that. But not to worry, we'll set that to a blank for our final release version. Our label is going to be located at y -50, which places it just underneath the tower image. The tower parent also has an orange highlight component. It's a sprite. It's sourced from our Graphic Assets Atlas, and the default animation is the orange highlight, and it's located at x of 0, y of -5 with a z of 0.1. It provides basically this orange, yellow, red shield, if you will, that we're going to be using to highlight those towers that are in our tower assets box prior to their deployment. And now we have 3 collision objects that are going to be components to the tower parent game object. And the distinctions between these is pretty important. So let's go ahead and move to the whiteboard. So as we said, we have 3 distinct collision objects. The first is the drag collision object. When a player touches or contacts this collision object, a message is going to get generated that initiates the dragging operation, unless the tower is already in position, which we'll see when we walk through the tower action script. The second is the range collision object. This is similar to how we manage range for the tanks. But for this one, when an enemy tank enters, aka triggers, this range collision object, the message starts the code associated with fire engagement. Lots of fire management issues need to be addressed, and we'll review those in the next tutorial. And lastly, the tower collision object reflects the actual body of the tower, aka that's the area which collides with an enemy tank's fired bullet. So when triggered, this is the effect that the bullet has determined within our script. So we're now ready to walk through each of these collision objects within the tower collection here in the outline window. First, let's look at the drag collision object. As we see here in the properties window, it supports a trigger in terms of its collision type. And we see that it's had a group mask of tower drag and a mask of def pause or cursor. In other words, only the collisions between tower drag and def pause or tower drag and cursor are going to be processed. The drag collision object is associated with a box shape that has a 40 pixel by 40 pixel dimension. Now let's look at the range collision object. The range collision object also supports a trigger type collision. It has a group of tower range, and it has a mask of tank body. That'll constrain this to only determining when an enemy tank is within its range. That range will be associated with the sphere shape that has a 180 pixel diameter. The tower collision object also associated with a trigger type collision. It filters the group tower body with 3 masks: a bullet, the tank range, and a cursor. And we can see that this collision object has a sphere shape associated with it that's of a 25 pixel diameter. So let's see how Tower 2 and Tower 3 are structured. I'm not going to spend much time here. As you can see, the collection looks pretty much the same. The only difference is the image associated with the tower body. It has a different sprite. It uses tower 2.1 as its sprite. And the size of the range collision object. In this case, the range is now 220 pixels versus the 180 pixels we had for tower number 1. And the tower 3 parent collection looks very, very similar as well. Again, using a different sprite image. It uses tower 31 as the default animation, all sourced out of the graphic assets atlas. And in this case, it now has a different range of 250. So the distinction between the 3 collections is the image that's used for the sprite on the tower body and the range associated with that particular tower. Tower 3 has a longer range than Tower 2, which has a longer range than Tower 1. As we look at the main collection, we have 3 prototypes, and we want to look at how the factories for each of these are accommodated. As you see, we have a Create Tower 1 game object, which is a container for the collection factory. And as we see in the property window for that collection factory, it's associated with the Tower 1 parent collection that we walked through in some detail here just a second ago. So we have a Create Tower 2. Its collection factory is associated with the Tower 2 parent. And we have a Create Tower 3 with a collection factory associated with the Tower 3 parent. Not all that dissimilar to how we saw the tank factory structured in the previous tutorial. Okay, you're now in segment 2. We're going to focus on our defensive positions. We're going to take a look at the game object prototype. We're going to see how that's constructed, and then we're going to go to the main collection, and we're going to take a quick look at the container and the factory that allows us to spawn multiple defensive positions all over our map sheet. As we know, the real crux of a tower defense game is to have the player select a tower by type, drag it to a location on the map, and that location will serve as a defensive position against the inbound tanks. Given that, the drag-drop action is the real heart, if you will, the real heart of the game. And the design for our Defold project is going to support that whole game approach based on 3 distinct elements. First, we're going to have multiple potential defensive locations located all over the map sheet, and we're going to spawn those as game objects, and they'll have a collision object associated with each one. Secondly, we're going to have a cursor game object that we'll use to manage user input actions. The cursor game object will have a collision object as a component, and we're going to use that to support touching a potential tower or dragging a tower. And then the third element of our design will be the logic inside our scripts that will support overall tower actions. So how's this going to look to a user? Here's a quick screen recording, and I just chose scenario number 1 to show this. As you can see here, you can see each of the defensive positions, a small little set of concentric blue circles, and they show the potential areas that you can deploy a tower. I've got a tower assets box down here in the lower left, and that's basically where those towers that haven't been deployed yet are associated with tower type 1, tower type 2, tower type 3. So I can actually pick, if I touch it, I can move a tower. And as you see, as I go over a potential defensive position, a green circle is going to show, and that'll show me that that's available for position. And if I let it go, it deploys it there, and then it respawns another type 1 tower in this particular case. So you have the next one you can deploy. So we have to be careful that people don't make mistakes as well, right? So let's take a tower 2, and let's say I just let go of it up here. But if it's not in a location that's not a defensive position, it's simply going to animate, bring it back down to the tower assets box, and nothing will occur. If I attempt to deploy a tower on top of a location where I already have a tower, the same thing occurs. It's just going to simply return it back down here to a tower assets box. So let's go through how the project supports all the features I've just talked about piece by piece. So let's go ahead and start with the DefPos prototype. As we see, the first component to the game object is a collision object, which is going to leverage a trigger type And we're going to filter using the group defpause against the mask tower drag. We have a sphere shape that has a diameter of 30 pixels. We have two sprites associated with the defpause prototype. The first sprite is an image that the user sees, which designates that the position on screen is actually a potential defensive position. And this sprite sources the defpause image from the Graphic Assets Atlas. The second sprite, Sprite 1, is the sprite image that will be displayed when the user drags a tower over a valid defensive position, that large green circle we saw in our quick demo. That uses the valid defpause image, again from the Graphic Assets Atlas. And lastly, there's a defpause script. Let's take a look inside that. As you can see, defpause.script, it's pretty short. After disabling Sprite 1, which is that large green circle during initialization, as we see, the script is essentially a message processor. It's aligned with the 4 message IDs that are sent out of the tower action script. The first, show field, simply enables shows Sprite 1. Hide field, hide Sprites 1. Disable CO disables the collision object, and enable CO enables the collision object. Well, now that we've seen how the defpause prototype is structured, let's move over to main.collection to take a look at how the factory is constructed. As you see here, main collection is open. And as we see, we have a game object container within the main collection called create defpause. And within there, we have a factory. If we come down here and we look inside our property window, that factory is associated with the defpause prototype that we just walked through. This design now provides the project with a convenient means for spawning multiple defense positions across the entire map sheet in all 3 scenarios. So now that we've seen how the defensive positions are created, the next segment is going to address the natural follow-on piece, which is moving the towers into those defensive positions. Okay, moving on to segment number 3. Segment number 3 gets into our drag and drop features. So we're going to focus on the cursor game object and the cursor script, which is the associated Lua script associated with that cursor game object. And then we're also going to look at our tower action script because of the interaction between our towers and the cursor to affect that drag and drop feature. So first, with the default engine here on the screen, let's focus on the cursor game object. A key element in our tower deployment design is the use of a cursor game object, because that's how we're going to manage the inputs associated with the user touching the tower or dragging a tower to a different position on the screen. So within the outline window with the main collection in focus, I've opened up the cursor game object, and it consists, as you see here, of 3 components. There's a collision object. Open up the properties window. It's the type of trigger. It's associated with the group cursor and 2 masks. The mask tower drag, which is the collision object within the tower collection that's used to initiate dragging the tower to a new location, and the mask tower body, which is a different collision object within the tower collections that's used to click on the tower body. For example, we're going to do that for making decisions related to upgrading or deleting or repairing the tower. We're going to be looking at that in a follow-on tutorial in this series. There's a sphere shape associated with this collision object, and the diameter of that shape is 10 pixels. The cursor also has a label component. Yep, another debugging tool that I thought would make sense to keep in the project. It'll let us set it up to any of the attributes associated with the cursor as we dive into how the logic is going to work. I've located it at an XY location of 0, 0. I've set it to a green color, and it pivots on the center using a system font. And saving, quote, the best for last, the real engine here is going to be the Lua script, cursor.script. That's what controls user input throughout the game. It's time for a syntax deep dive. Be forewarned. Hey, I'm going to go through this cursor.script very carefully. There's a lot of nuances here, and candidly, there's a lot of code reuse opportunity here, so it's pretty important you really understand it. To be honest, I'd recorded a much shorter video version of this cursor script walkthrough, but in taking a second look at it, I thought it was more important to really spend a little time to deep dive into how this logic works, because candidly, I've ended up using it in most of the games I work on. So here goes. I guess we can say take two. We obviously start with a comment header. That's a consistent entry, and the header summarizes the purpose of the script and confirms both the file name and the version. And as we see here, we have a local function. Tower is deployed. This function determines if a tower with the input parameter ID is currently deployed on the map sheet. To put that in context, within the controller script, we're going to see that every time a tower is deployed, that controller is going to add the tower game object ID to this deployed tower's global variable, which is a table. And this function looks in that table for the ID, returning a true if it finds it, or if it can't find that ID, then it will return a false. In terms of initialization in the init function, when the game begins, the init function does several initialization steps. First, obviously, it acquires input focus. Then it initializes several script properties. Let's take a moment and walk through each of them. You can see I've attempted to make sure there's a definition for each of these inside the script as a comment. So self.collisionID is the ID of whatever game object the cursor has collided with, whereas the self-touched group is the collision group associated with that game object that was touched by the cursor. We use self.pressed. We set it to true if the user is actively touching the screen and false if they're not. Self-dragged ID is the ID of whatever game object is physically being dragged by the player. And the self.dragged pause is the position of that game object that's currently being dragged. So last step here in the init function is it gets the current position of the cursor and places it into that script property self.actionPause. We rely pretty heavily on the onMessage message processor. Even though we've used it many times, let's go ahead and let's take a moment and refresh ourselves regarding the structure of that syntax. So this is going to be the first of several syntax deep dives here in this particular tutorial. Again, we're going to focus on the onMessage. So as highlighted, the onMessage function receives three key input parameters. Message ID. This is the name of the message, which is hashed. Second is message, and that's the message data, which is going to be passed. And that's going to be in the form of a Lua table. And then the third input parameter is sender. And this is the full URL of the sender. Now, we use each of these parameters pretty frequently, especially in support of more complex designs where data is being passed between scripts. And this enables us to control data manipulation. aka, we really want to minimize the use of global variables because excessive global variables in any project tends to lead to poor programming practices. And as I found out the hard way, and I'm sure you have too, a lot of difficulty in debugging. So let's go ahead back to our cursor script. Here we're only processing a single message ID, the collision response message. So we see that a lot. So I'm going to divert yet one more time and go ahead and do a syntax deep dive into the collision response message format. This is the message that reports a collision between two collision objects. It's only sent once per colliding pair at that very first frame. You can control how the two objects collide using group and mask. Group is the name of the collision object component of the game object, and mask is the name for any other group that game object should collide with. When you receive a collision response message, there's some key information that's passed to you in association with that collision response message. There's other ID. Again, that's a hash of the ID that the object just collided with. Other position is in vector3 format, and that's the position of the object that's just been collided with. And other group is the hash of the group that the object collided with. Now that we've refreshed our memories regarding onMessage and collision response, let's get back to how our cursor script uses those features. First off, It only processes the collision response message if several conditions are met. First, self.collisionID is nil. That means there's no other game object already collided and being processed by the cursor. Or alternatively, the z-index of the object that's just been collided with is higher than the z-index of any other object that's been collided by the cursor. Therefore, it's the uppermost object and therefore takes priority. If those properties are met, the self.collisionID is set to the ID of the topmost game object pointed to by the cursor object, and the self.touched group is set to the group of that object pointed to by the cursor object. Just for completeness, we do have a final function, and that releases input focus at the end of the game when the final function is executed. Update. We all know that update's called each frame, with the variable dt being the time difference between the current frame and the previous frame. Within the cursor script, for each frame, self.collisionID is set to nil. That'll start a new cursor collision determination each frame. And the position of the cursor is obtained using geo.getPosition, and then the x and y positions are rounded to the nearest integer and set within a string for the text of a cursor label. And we're using that cursor label for debugging purposes, and we'll blank it out for the final release. On input, this function receives all the input actions from the user, providing the action ID and the action. Yep, hey, I'm on a roll. Let's divert one last time to review the on-input syntax. Now, you're probably asking why. We've looked at it before, we've used it before. It's primarily because I tend to receive queries from folks asking questions on some specifics of how the function's being used. So let's spend a little time on a deep dive just to be preemptive. User input is captured by Defold, which is then processed by the onInput function, given that the object has acquired input focus. A couple of parameters. Action ID, that's the name of the message as set up within the input bindings. Action, we're going to use that one a lot. That's a Lua table that's passed, and it provides you with several key elements that you can therefore use and process in the onInput function. There's action.pressed, which is set to true during that first frame that the input action was detected, for example, touching the screen. There's action.repeated. That's true if that input stream is repeated. Pretty obvious. Action.released. That's set to true in the frame where the input was released. For example, you remove your touch from the screen. And then there's action.x and action.y, which are the x and y locations where that actual input occurred. Okay. Hey, sorry for those syntax deep dives, but you see the logic within onInput here within the cursor.script is highly dependent upon knowing how to apply those parameters. So let's go ahead now and walk through the logic. The first step when we start onInput, the logical defold cursor position, self.actionPause, is set to the current position of the machine cursor, which is action.x and action.y, where the action occurred. And a local variable, tower dropped, is set to the self.draggedID. Now that self.draggedID can either be a nil if no tower is being dragged, or it can be the ID of a tower which has been previously initiated due to drag actions and hasn't yet been released. Several actions occur when the user either touches or releases the screen. When the user touches the screen, the collision object is enabled and self.pressed is set to true. When the user releases touch from the screen, three things basically happen. It disables the collision object and therefore stops processing any collisions if the user is not touching the screen. It resets the self.pressed, the self.draggedID, and self.dragging script properties. And if the dragged ID doesn't reflect a tower which is already deployed, it sends a message to the tower that's been dropped to release that tower. When a user touches the screen and the cursor's collision object also collides with the drag collision object of a tower, then several steps are going to be applied. If the cursor is collided with another game object and it's not already dragging a game object, then the user starts to drag a new tower. The script sets the dragged ID to the collision ID and the dragged position, dragged pause, to the current cursor position. Then a message is sent to the dragged ID, the tower being dragged, to, quote, increase the scale. so that we're dragging it. It's slightly bigger than it would be when it's stationary. If the user's clicked a game object which hasn't already been deployed and moves it, that's where it sets self-dragging to true, and it sets the global variable dragging to true. And then lastly, the position of the dragged game object is updated based on the action pos.x and the action pos.y that's provided by the onInput function. And a debug message is set to display that final location on the screen. We had said earlier that there were three major elements that support the tower drop and drag feature. The spawning of multiple potential defensive locations, that's the def pauses, and the cursor game object that's used to manage user input actions to include touching and dragging a tower, and then the logic behind the script supporting overall tower actions. Hey, we've walked through the first two. Now it's time to dive into the logic embedded in the tower action script. You can see we have a standard script header here with a short overview. And then we define a set of script properties, and I've provided inline definitions for each. And then quickly you can see that pdef_id is the ID of the defensive position that we're dragging the tower to. And then pposition is the location of that def_pos tower we've been dragging to. We have the type of tower. It's a tower type 1, 2, or 3. We have a Boolean valid position, so that'll determine if the position is okay for the tower to be placed for many different reasons we'll see. Then it'd be true, else it's false. Each tower has a number of strength points. The Boolean associated with deployed is if a tower object is already deployed or if it has not yet been deployed. The current angle of the tower in quaternions, because the towers are going to rotate to point at the inbound tanks that they can be within range. And then we have the bar strength. So we have a strength points, and then we have the number of bars that are underneath the tower that reflect how strong it particularly is. Now, notice these are script properties, so these are going to be unique for each instance. There's going to be multiple towers, and therefore each tower has its own unique position, type, strength points, whether it's deployed or not, whether it's been upgraded or not, things such as that. So that's why it's important that we use a script property here, not a local variable. Very similar to what we saw when we were looking at our tank pointing at objective, we have a local function here called point towards tank, which supports having a tower point its gun at a designated tank. And note that the logic is only applied if the designated target, self.target, is an active tank or is the tower's generic aiming point. Now here, the angle from the tower to the designated target is computed first in radians using the math.arctangent function, and then it's converted to quaternions. That's consistent with the deep dive we went through back in tutorial number 2. For towers, the entire tower body is going to rotate towards the objective. There's no separate turret on our towers like there was for tanks. Initialization. In the init function, several additional script properties are initialized here. We have the original position of the tower when it was initially spawned. We have the current position of the tower. We have the ID of the tower instance. We have a vector3, which is the current position of the target that the tower is looking at. We have a Boolean, is the tank been destroyed or not? True, yes. Destroyed equals false would be no. And then we have the URL of the strength indicator sprite. The strength point indicator is initialized such that each bar equates to 40 strength points. Now the bar strength is self.barStrength. And then the SI sprite is set to the applicable single image animation group associated with the number of bars, which is bar strength divided by 40. Both the range and the tower collision objects are disabled when the tower is initially spawned. And then the self.target is initially set to the aiming point, which is 10,000 pixels above the game screen. So basically it forces the tower to point straight up. And then lastly, A game object animation is conducted when the tower is initially spawned, which starts the scale at 0.1 and then animates it up to 1.0, so it kind of blows itself up as it comes up. And then finally, a game object animation is conducted when the tower is first spawned, which changes the scale from 0.1 up to 1. Update. For each frame, which our target is 60 frames per second, the following logic is going to apply. Then we're going to have the tower point towards the tank. That's called each frame. And then if the tower is already deployed, strength points are going to be placed in the label. That's mostly for debugging purposes so that we can keep track of this. Now notice that there is a bypass to this, so it's relatively simple to remove these for the final release. And then both the range and the tower collision objects are enabled as part of the update process. But if the tower has not been deployed, in other words, it's still in the tower asset area, then the drag collision object is enabled. Now to wrap up the tower action script walkthrough, let's go ahead and take a closer look at each of the message IDs that are processed by the onMessage function. In our first condition, there's a trigger response, and the message of the other group is the def pause, the defensive position. So what that means is that you have moved your tower, you've dragged it, and you've dragged it such that it's now colliding with the collision object of a def pause, which means it's next to a def pause. It's on top of that. And also, you haven't been destroyed yet. So when the message.enter is true, that reflects entry into the trigger collision. In other words, you've now dragged the tower. It's sitting on top of a possible defensive position. And when this happens, we're going to set the following script properties. The p def ID to the we're going to set that to the ID of the def pause you collided with. We're going to set the p position to the position of the def pause you've collided with. And we're going to send a message to make sure that sprite 1, which is that large green circle indicating that you're above a potential defensive position that's available, we're going to make sure that that's showing. Now when message.enter is false, that's associated with exiting from the collision. And so when this occurs, we're going to send a message to hide all the images because we don't want any large green circles. It's time to move to another potential spot. When the message ID is, quote, dragging tower, and the tower has not yet been successfully deployed, we do two things. First, we apply a scaling factor to increase the size of the tower sprite, just to highlight it a little bit. And then we're also going to disable the shield. We call it the orange highlight that is shown in the asset box while we're dragging it. So we're going to remove that shield from the image as it's dragged. The next trigger response that we want to look at is when a tower is within the effective range of an enemy tank. Upon entry, in other words, message.enter is true, we want to set the self-target to the ID of the tank. Upon exit, we want to reset the self-target to the aiming point. And the last condition we want to check for is when the message ID is released tower. This is when the user actually releases the tower and is hopefully on top of a potential defensive position. If it is a valid position, we're going to post a message to hide sprite 1. We're going to hide that large green circle, and we're also going to disable the def pause collision object. The tower's range and the tower collision objects are enabled, and the drag collision object is now disabled. We're going to set self-deployed now to true because it's now an officially deployed tower. And we're going to put that ID into the global variable deployed towers, which is a table. And then a message is sent to the controller to replace the tower within the available asset area, so now you have the ability to deploy another one. However, if the player releases the tower and the position is not valid, then we're going to have it go back to its original position within the tower asset area and enable the orange highlight, the shield, to reflect that. Okay, time for segment number 4. Segment 4, we're going to really focus on some of the Lua script. We're going to look at the changes that we've had to make to our controller script in order to affect the drag and drop capabilities. We're going to take a look at our script, GUI script associated with the main menu, mostly associated with adding that tower assets box down to the bottom left-hand corner of the game screen. And I think you're going to find it helpful. I've got a number of deep dives that are going to really hone in on some of the defold scripting capabilities that are really important to not only this, but any major complex game you might be interested in developing. Let's start with the main menu graphic user interface. If we look at main menu GUI within the Outlook window, we're going to see that the textures, basically the 3 atlases that we've referenced, the fonts, the 3 fonts, and the layers, rule of 3s here, the 3 layers, are consistent and the same as what we initially set up in tutorial number 1. Now, if we look at the list of GUI nodes, however, you're going to see 2 new nodes, a tower assets box and a level banner. Let's take a quick screenshot just to take a look at what they look like. As you see, the tower assets box is really just an image. It's got a black brushstroke, which has a child text node superimposed on top of it. The towers that are placed to the right of here really aren't part of the graphic user interface. Those are actually the spawned game objects that the controller spawns as part of their active tower collections. Going back to the graphic user interface, we see that we've placed the tower assets box at an X of 130, a Y of 55. We've used the texture of brushstroke out of the pop-up assets atlas. And we've placed this in the button layer. Text 2 is a child, and that's centered at the parent, 0, 0. And it's scaled down to 0.4 so that it's an appropriate size. We've initialized the text to tower assets. We've changed the color to an off orange, as identified here in the properties window. And we've placed this text in the notices layer. That will place it on top of that black brush stroke, and we've set the pivot to center. The level banner is our victory indicator. That's also a new node for this build 3. We've located the level banner in the center of the screen at 512 of X, Y 384. We've set the texture to the red victory banner out of the graphic assets atlas, and we've placed it in the notices layer. Well, that was pretty painless. So I have to admit, I seemed to spend quite a bit of time when designing and developing a game on the look and feel of that graphic user interface. Finding the right images and placing and scaling them to improve the aesthetics, it really does contribute to the quality of your game. Now let's take a look at the graphic user interface script associated with the main menu. So I'm going to go ahead and use our diff now tool just to compare our build 3 version of main.GUI script with our build 2 version. Very, very small changes this round, keeping it simple. Keeping it simple is a good thing. We can see that within init, we do have a script property that we set to the node associated with the tower assets box. And then we do disable that during the opening animations. And then in our onMessage process, when we disable the control nodes, when we process that message ID, we have now added disabling the tower assets box. And now we have a new message ID called enable control nodes, and in that we enable the tower asset box GUI node. That's it. All right, let's take a quick 10,000-foot view of the controller script using diff now before we jump into the details of the code. We've got a couple new global variables. We've added a number of variables associated with tower characteristics. We've provided some defensive position coordinates. We've added additional tables for collecting the IDs of both defensive positions and tower objects, capture those IDs as they're spawned. We've got now two global functions, one that we've had before for tank active and now a new one for tower active. A couple of local functions, deleting all of the entries associated with defensive positions or all the entries associated with tower entries. We made a couple changes to our start selected level local function. We're now spawning icons for the defensive positions. And we're also spawning towers for the tower assets bar. We obviously update our pop-up to reflect the changes. And we also spawn available tower defenses as replacements. And then we've added two new messages. One is to delete the tower collection. The other is to hide all the defensive position collision objects. Well, now that we've summarized the changes in the controller script using our DiffNow tool, let's go ahead and open up the code editor and do a deep dive into the specifics of that syntax. I've got the controller script opened here. And we're just going to look at changes. So as we see, we have added a couple global variables. We have a variable now which is a pause status flag that's initialized to false. We have a dragging status flag that's also initialized to false. We have a number of tower characteristics that are identified, the number of tower types and designations for each of those three types. And therefore, we use those as the indices for things such as our tower strength points, the cost for each of these towers, and these are just plug numbers right now. What resources are gained when you destroy a tank by type. What health points are lost when you lose a tower, again, by type. And the capturing of our deployed tower IDs into a Lua table. We do capture a counter, if you will, for the total number of towers that have been spawned. We initialize the coordinates of each of the defensive positions. We do that on an X and Y basis, and we do that for Scenario 1, Scenario 2, and Scenario 3. We do establish two additional Lua tables for capturing the IDs of all of the defensive positions, all the objects within the defensive positions that have been spawned, as well as all the objects within the towers that have been spawned. We've added a tower active function that will return a true if the tower URL is still viable, and it checks that in the spawned tower objects Lua table. We have two new local functions. We have the delete defpos entries, which simply goes through the entire spawn defpos objects table, deletes each of the objects within it, and then sets that table to nil. And an analogous function, again, local function for deleting all the tower entries by going through the spawn tower objects table, deleting all of the objects, and then setting that to nil. Within the start selected level function, you can see that we spawn all the new defensive positions. We do that identifying using the coordinates that we had in our defpos X and Y tables that we initialized earlier. We use the defpos factory, and then we insert the IDs into the spawn defpos objects table. Analogously, when we initialize a new level, we spawn our tower assets, type 1, type 2, and type 3. We set up a props table, a properties table, and then we pass that to the factory as part of the collection factory create function. We capture the IDs associated with those, the IDs of all the objects, and we add them to the spawn tower objects table, and we increment the counter. And again, we do that for tower 1, 2, and 3, passing along the cost, the tower type, and the strength points. As I go to message processing, there are two additional message IDs that we process. First is deleting the entire tower collection. Again, we go through the spawn tower objects. We identify the hash of the ID. We remove the entries from the table, and then we delete the actual game objects. And the second is hiding all of our defensive positions, where we go in and we delete and hide the field, if you will, for the green circle in this particular case that shows the defensive position. Enemy tank action.script is the last script file we're going to deal with in this segment. There's only really a few minor changes that we've made to the enemy tank action script based on the addition of towers. The first is within our function point towards objective, we now make a conditional that has to check to ensure that self.target is in fact an active target. We do identify a couple new script properties. And in our message processing, we're now processing a trigger response where the own group is the tank range and the other group is the tank body, which sets the target to the ID of that tank. So let's go ahead into the detailed script and see what that looks like. Okay, at the risk of being really repetitive, this is going to be super quick. I'm just going to jump in, take a quick look at what we just saw in our diff now comparison. We have added an additional conditional to the point toward objective function. It now checks to make sure that self.target is in fact an active tower. We've added an additional script property, destroyed. And the final change is associated with the trigger response in the onMessage function. With our trigger response, if the own group is the tank range, the range of the tank that this enemy tank action script applies to, and the other group is a tower body, that means that that tower is now within range of this tank. So we're going to set the self-target to the ID of that tower. Hey, finally, we've reached segment number 5. This is our wrap-up segment. If you've not built your program yet, go ahead and build it. As I've built mine, the final outcome, I'm not going to show the whole thing, simply would take too long. But let's just hit the highlights. What have we added this tutorial? Well, we've added the ability to place towers, spawn them, spawn defensive positions, and move them around. So here you go. You can see the defensive positions around the screen. You can see that I've got 3 towers, one of each type, down in what's called a tower assets box. I have the ability to drag and drop a tower. If I roll it on top of a valid defensive position, a little green highlight circle shows up underneath it, just an indicator that it's valid. If I let it go, it deploys the tower to that location. If I drag a tower and I simply drop it someplace else that's not a valid defensive position, it animates and brings it back to the asset box. If I attempt to stack and put 2 towers in the same defensive position, it doesn't allow me to do that either. And when I let it go, boom, an animation occurs and brings it back. Let's bring tutorial 3 to a close. What was the Perl? The Perl was the cursor script. That was the real gem that you're going to find has lots of reusability. The ability to drag and drop, whether it be with a mouse on a desktop or a finger on a tablet, that's the element that you're going to be able to deploy to many, many, many different games you might be building. So that's the one I spent probably too much time on, but hopefully that's been helpful for you. I hope this whole tutorial has been helpful. And if you should have any questions, please send me a comment. Send me a question down here on the YouTube comment section. I look at those every day and I'll get right back to you and try to clarify as best I possibly can. If you're not a subscriber yet, please do. I appreciate that. That means a lot to me, and it also gives you an ability to get notified as I start releasing additional default tutorials here. Most importantly, I really want to thank you. Put a lot of time and effort into these tutorials, and I really appreciate the comments and the feedback people are providing. That means a lot to me. Next tutorial number 4 is going to be related to fire exchanges. Okay, we're going to start getting some action between tanks and towers. I think you're going to find that really, really interesting. So we'll see you next time.